Okay, so the next transformation that we look at is what happens when you have negatives in your equation. With parabolas, if the negative was outside of the function, you already learned that that made it go down. So you've seen negatives in functions do some effects already. Now, that negative outside of the function that you saw with parabolas is this first part. Does it make sense that that would flip it down? And so anytime you have a negative outside of your function, that reflects it over the x-axis. And we'll call that a vertical reflection. And you'll start to notice that everything that happens outside of our function is always vertical, right? In the last part, if you added something on the outside, that moved it up or down. Now, if you have a negative outside of your function, that reflects it up and down. So everything outside of our function is vertical. And anything inside of the function, so if your negative is with your x, that's going to take your graph and reflect it over the y-axis. And we're going to call that a horizontal reflection, because you're flipping it over the y-axis. So our additional notes, which you can put right beside that graph. We'll start with y equals f of negative x. If the negative is inside, I'll put that if the negative is inside the function, in other words, the negative is with the x, then this is a horizontal reflection which means you reflect over the y-axis, and the x values get multiplied by -1. So it flips your graph over the y-axis. And when I say the x values get multiplied by -1, I'm going to show that, okay, I'll bring it back down again, but let's pick a random point on our original graph. Let's say this point here was 5, 7. If I flip that over my y-axis, okay, can you see that it would be this one there on the opposite side? And the coordinates of that point would be -5, 7. The x coordinate is just getting multiplied by a -1 because the transformation says you're replacing your x with a negative x, with that negative there. So down here at the bottom, when I say the x values get multiplied by -1, we can now think of a single point and know exactly what happens to that single point. All that's going to happen is your x values are going to get multiplied by -1. If we have y equals -f of x, can you see that if you multiplied both sides, some textbooks will write it like this: -y equals f of x. Now, we are always going to do the first way where we like to have the y by itself. Okay? But we're going to write if the negative is outside the function. Does that make sense, that negative being outside of the function? It's not inside the function. And we can technically say here with the y, because you could move it over to the other side so it could be with the y. But I like to have the y equals by itself, so I think it's best just to think of outside of the function. If that negative is outside of the function, then this is a vertical reflection. That's flipping it over the x-axis. And the y values get multiplied by -1. So the negative being outside, that is going to affect things vertically, meaning that it's going to affect your y coordinates. Everything that's vertically affects your y coordinates. Everything that's horizontally affects your x coordinates. So if we go back up, and I'll scroll back down again, what's going to happen to 5, 7? If I flip that over the x-axis, my x-coordinate doesn't change, but now my y-coordinate becomes -7. And all that's happened is I've taken that y-coordinate and multiplied it by a negative. So with that in mind, we can go to example 1. And so you'll notice on this video, that introduction part I thought was important, so I included that introduction, and that will be part of example 1. So sometimes I'll make a separate introduction video. This time I'm going to just group it together with example 1. And it says, here's a graph of y equals g of x. Sketch the image of the graph after reflection in the y-axis. So when I see this reflection in the y-axis, I think about my y-axis, and I think about a point on one side flipping over the y-axis. What changes, the x-coordinate or the y-coordinate? The x. So this is horizontal. And if the x-coordinate's changing, I'm also going to think in my head, that means the negative is with my x. So we have to be able to translate the reflection over the y-axis into function notation, into horizontal or vertical, right? Sometimes they're going to say a reflection, the same question, they could say a reflection in the line x equals 0. And you would have to think, you know, with our asymptotes, x equals 0 is a vertical line. That's your y-axis. So they could ask the same thing in a number of different ways. Okay? What does this mean? This means we're going to multiply our x values by a -1. So here's a point. This point is -3, 1. If I multiply my x coordinate by a negative, can you see that you would flip it over here and get 3, 1? A second point, -1, -2. If you multiply your x coordinate by a negative, you would get +1, -2. And if you did this to each of these points, here we have 3, -2, so we're going to have -3, -2. Here we have 5, 2, so now we're going to have -5, 2. Connect your dots, and you've got a graph of the reflection. State the domain and range of each. So my original one, which in my graph is red, my domain, my smallest x value is -3. My largest x value is +5. My smallest y value is -2. My largest y value is +2. Then on my green graph, for my domain, looking at my graph, now my smallest x value is negative 5. My largest x value is positive 3. Looking at my graph, my smallest y value is negative 2. My largest y value is positive 2. Okay. I got my domain and range from my graph. Getting a domain and range from a graph is probably the easiest way to get a domain and range. This question, though, they could have told you there was a reflection, not giving you the graph and just giving you the original red domain and range. Can you see how you could have gotten these answers if you had the red answers and were told there was a reflection over the y-axis? If it's a reflection over the y-axis, what's changing? X values. Notice the range didn't change. The range are my y values. So could you have said right away easily, oh, my range is going to stay the same if I didn't have the graph? And then if my x values are the ones that are changing and my x values are multiplied by negative 1, can you see how this worked? That negative 3 would become the positive 3. And the 5 would become the negative 5. And in interval notation, you're always writing from your smallest value to your biggest value. Okay. Reread the question. Hey, we've solved everything. Awesome. Questions 3 and 13.